Hi, I'm Dr. Fred DiPiero. You can call me Dr. D. I used to wear a tie, and I'm glad I don't anymore. I think I like my Memoji better than my pics. I'm a little less self-conscious with it. By way of introduction, let me say that I am a PhD level hobbyist. I'm a real geek. I encourage hobbies. You can learn a lot. And the good thing is, too, there are no due dates. Yeah. My goals for this course are to demystify circuits, voltage, and current flow, and help you develop your qualitative and quantitative understanding of circuits. Now, if you're an EE or CPE major, this is going to lay the foundation for a lot. Non-majors who might be taking this course, welcome. EE subsystems will likely be very helpful in your career. Frankly, it'll be hard to avoid them. And this also could provide a very helpful preparation for the fundamentals in engineering exam, which is the first step to becoming a licensed professional engineer. So why do we take so many analysis courses like this circuit analysis course? Well, engineering curriculum can be broken up into 4 components. You got your basic math and science, physics, chemistry, math through differential equations and so forth. Then engineering science, then engineering design, complemented by general education. Analysis courses fit into the engineering science segment. They're going to include things like statics, dynamics, intro to materials, programming, heat transfer, thermo, and circuits. Yes. Analysis courses are important too, because in general, they're going to help prepare you for engineering design. Most design efforts involve top-down and bottom-up efforts. The final effort usually meets in the middle somewhere. Top-down is a process where we break down high-level requirements into smaller pieces. Bottom-up, we work from prior designs or approaches to match identified needs. Analysis helps with the bottom-up part. It allows you to examine opportunities to modify prior efforts, for example, to scale them up, scale them down, see if they might operate in new environments, whatever other creative variations you can dream up. Now, there's going to be 2 sorts of classes of analysis that we'll be doing in this course. First, I'll call systematic, and the other is ad hoc, less systematic. The systematic methods, you follow the steps, 1, 2, 3, you're going to be able to analyze any circuit that gets thrown at you. Now, the ad hoc methods, they sort of have some pluses and minuses, if you will. They involve simpler calculations, so that's always nice. But the analysis process may vary. The specific steps may vary from circuit to circuit. I can't tell you exactly what the order of steps might be that you would have to apply. Furthermore, they can't always handle every last circuit. Nevertheless, good to know they are simpler. I would respectfully recommend to you that you try and develop your abilities in both of these areas, the systematic and the ad hoc. Systematic methods will help you with your quantitative abilities. Ad hoc will tend to help you more with your qualitative abilities. Both are important. They reinforce each other. So what's it going to take to get an A in this class? Well, let's say an A, you're proficient in both the quantitative and qualitative methods, and you're able to apply these techniques in new situations. For a B, well, let's say you're okay with each of those methods. Maybe you're a little stronger in one than the other, perhaps. And sometimes maybe challenged by new situations. For a C, well, maybe you're not strong in either the quantitative or qualitative, and I won't go to any other letters at this point. I look forward to working with you, and I have confidence that you'll do well.